Hey folks, welcome back. A lot of questions over the last week have been about how to take some of the work we did last week, which is about using Opencv inside of the new script top, and actually dump some of that data out into TouchDesigner so we can use it for a variety of different processing. Now, this isn't too hard, and actually we're going to do a lot of the same process we did before, and then I'm going to show you two different ways that you could take that data and output it into your project. So first and foremost, I'm going to open up the Opencv documentation here, and on the same page we had open last time, this Harris corner detection. We can scroll down a bunch, and this is the example that we had copied and pasted over from previously into our other example. And one of the problems with this example, and I shouldn't say it's a problem, it's a very basic example, but it really only just colors the pixels right back on top of the image. It doesn't really give us points of reference. It doesn't give us centroids or positions of those pixels. It kind of just goes through all the pixels and says, does this pass a certain threshold? Make it red. Now that's not super helpful for us, and we actually do need an in-between step, which luckily is kind of in the next example right on the page here. So corner with subpixel accuracy is a very useful example because not only does it take what we were doing in the previous example, takes it a little bit step farther and gets you even more precise corners. You can see an example here. The green points would be the output of this example versus the red points being the output of the previous example. So this will give you not only better accuracy, but the great thing about this is that the example goes a few steps further to actually get all of the corner points out of this connected components with stats function. It actually gets centroids, stats, labels, all these other things, passes them to the corner subpix function, which gives us the subpixel accuracy of detection for the corners. But then it gives it to us all in a beautiful array, basically a list of X and Y positions for where all of these different items are. So if we're gonna kind of run through this process again, similar to what we did last time, we can go through this and make a new script top in TouchDesigner. And here I just basically have my camera coming in through NDI, down-resing it just like we said last time, because a lot of the time you don't want to be sending these large resolution textures into this Opencv process, especially since we're using Python. It's going to be quite a bit slower. So whenever you can minimize your resolutions, you're going to get your best bang for buck. So now in this default script top, I'm going to go ahead and edit the contents of the callbacks. Let me drag this over from my other screen over here. And I can go ahead and basically delete everything in the on setup, and I'll go ahead and just delete this first line of the on cook, which is generating that noise for us. And now we can do very similar to what we did before, which is, let me put this up on this half of my screen. Let me get this documentation on the other half of the screen, and we can begin porting over this example into our script top. So I'll start from the beginning. I'll grab the imports, put those at the top. And remember, by default, the script top has import numpy, but what you're going to see a lot over the web is import numpy as np. So I'm just going to go ahead and use the import statements from the example. We remember that the first few lines are usually going to be how these examples read in a file, and then turn that file into a numpy array. Now in our case, we actually have that very helpful method that we saw before, so I can actually just reference my null here. Let's do here. So this will be my texture equals op null1. And then if you go to the Python help, you'll see that all the tops now have this really great new method called numpy array, which will give you the contents of that texture as a numpy array. So we're going to go ahead and use that. .numpy array. And I'm going to set the delayed to be true in this case, just to get a bit better performance, even though it'll be a frame behind. That's fine for me. And then if we go back to our example here, we can see that that is going to be our image. So actually we can go ahead and just rename this to image. Now the great thing from here is, like I was saying, if you set up your inputs correctly and you set up your imports correctly, you can go ahead and more or less copy and paste a lot of these examples right into TouchDesigner. I still highly recommend looking through the documentation, learn about Opencv so you know what you're using. Just to get through these videos a little bit quick, I'm just going to copy and paste this code straight in here. One thing you're going to need to make sure to do is fix the indentation, because we can see here all of these lines I pasted in are not indented correctly. So I can go ahead and use the magic of Sublime to push them all in one indentation level. And I can go ahead and save it and make sure there is no error, which there is an error. And we can see A is not defined here on line 33. So let's hop back into our code. And we can see on line 33, oh, that's because we got rid of this from before. So actually we can go ahead and just put image. And that's going to take our input that we're copying as a NumPy array and just output it to the output for now. We'll come back later to what you can do with the outputs, because in a lot of cases, maybe you don't actually need any kind of output, right? You can maybe even ignore some of those outputs. But in the meantime, right now we have essentially what we need for our detection here, and we're left with this data set, these corners. And what we can do is go ahead and actually print some of these corners. Now, I'll say this with a warning: if you're on a slower system, really be careful about printing data. If you haven't printed data from big scripts before, it can very quickly slow a project down to a halt. And you'll see here, as I'm printing, I'm either going to be pausing my timeline in TouchDesigner, or I'm going to be commenting and uncommenting out that print line very quickly, just so we can get one printout and then have it not print anymore. Because what you'll see very quickly if I do this, if I go ahead and print corners and I save it, we can just watch the FPS quickly tank down to a halt as it's printing. But if I clear the text port, you see my frame rate jumps back up. And this is something you just got to be careful of. So what I like to do is print once and then comment it out. And you can see once I stop printing all this massive amounts of data, my frame rate jumps back up. So we can see here what our corners are is an array of arrays. That means we have a list starting from index 0 going up to whatever index it's going to go up to. And each item inside of the index, so index 0, is actually going to be another sublist. And the first part of that data is going to be the X position, and the second part is going to be the Y position. So as we're going to iterate through some of this data, we're quickly going to find some easy ways to just blast through this list. And then as we're blasting through, just grab the XY pairs out of it. So now that we have kind of this data ready for some kind of consumption, there are a number of different ways that we can get access to it. And I'll be frank in saying that none of them are very ideal, and none of them are super smooth and super fast. And there's some trade-offs. So for example, if we wanted the easiest way that we could get access to this data, what we could do is go through a process of having a table dat, going through this list of X, Y positions and dumping those out into a table, and then having a table go into something like a dat to chop, which is going to give us those values as chop channels. So if I was going to go through this process, first thing I would do is make a table dat. And I don't really need to worry about doing anything with the table dat, because essentially every frame, I'm just going to clear it out and then dump new rows into it. So I don't care about headers, or I don't care about rows or column numbers or anything like that. So I can hop back into my script here and I can say op table1.clear, because we know every frame we want to clear it. So now what we can do is we can go through every item inside of this corners list and basically append a new row for each item. So you can see I'm using the words for and going through, and this should give you a hint that we're going to use a for loop. So there are many different ways to approach it, but probably the easiest way and probably the most straightforward way is just to try different things and print them. So for example, I could say for I in corners, so we can even just go straight and iterate through the list. Let's print I and see what happens. And again, I'm going to be very cautious with my printing so as not to tank my machine. So we can see here, this is actually pretty nice, because what it does is it gives us each pair of positions, the X and Ys, as a separate line item. So we could probably go ahead and even just say, well, for I in corners, op table1 dot append row, open up a set of parentheses, and don't forget, we have to open up a set of square brackets. We'll put our I there. And let's see what happens. And actually, I'm going to turn off this print statement here. So now you can see that we are getting every XY pair put inside of our row of our tables here. And we can see it's about 30, average around 30, depends on what's on screen. If I start bringing more things on screen, like my hands, we can see it goes up to 100 rows. But this is not super helpful because it's putting our list of XY positions into each cell, whereas I want one column for my X and one column for my Y. Now this is where it's helpful to know what Append Row is doing. So Append Row, remember when we said put in these square brackets? Normally you're going to need those square brackets because Append Row wants you to give it a list where each element in your list becomes a separate column. Now in this case, because our item is already a list, we can even cheat and just get rid of these square brackets. And then I can save that. And what we're going to see is now we have this very clean X position column and Y position column in pixels. Now this is great because, like I said, it's very easy to take something like this and do a dat to chop, take my table, drag it onto the dat parameter, and then what I want to do is set the output so that I get a channel per column, because all of these are my TX positions, all of these are my TY positions. So I can say channel per column. And then what I have to do is define the naming and value system inside of my table. And what that means is by default, it's expecting that maybe the first row is going to be values, but the first column is actually going to be header names. And that's why we have this issue here where we only have one channel. But what I can tell it is that, well, actually our first row is values and our first column is values, which basically translate to saying that we have no header row or columns. Everything in the table is values. So once I set my first row to values and first column to values, we can see now we have this X channel here and this Y channel here giving us all the pixel positions as they're related to the lower resolution, obviously. So if you wanted to, composite some objects back on the higher resolution, you put a math chop in here, scale those values back up to the full resolution. But essentially you have this data now in an easily accessible chop format that you can work with, whether it's instancing, or you could use select chops to pull out different pieces of data from it, whatever you want to do in that case. So that's kind of the quick and easy way of setting it up. It's not really the highest performing way because oftentimes we don't want to do things like this in TouchDesigner where every frame we're clearing a table and every frame we're kind of writing back to it. That's kind of a suboptimal workflow. So a different way that we could approach this, and let me actually go into my script here and just comment out those lines. A different way we could approach this is, since we know that we have an object here, corners, and it's an array of arrays for the XY positions, what we could do is actually save this into our Python storage of our script top here. Then we can go and make a script chop that reaches into that storage, grabs all that data, and just parses it out into dynamic chop channels for us. Now, if you haven't used script chop before, I know this might sound a little bit daunting, and now if you haven't used script chop, now we're using script top and script chop together. It's script operatorception over here, but don't worry, we're going to step through this together, and it's not super difficult. So the first thing is that inside of our script top, what we actually want to do is, now that we have our corners, we want to take that data and store it inside of our op storage. So we know that we have a reference to our self here, the script op. So I can say script op.store. And then I really just need two arguments for the most basic version of this. One is the name of the data set that I'm going to be putting there, so that when I go to fetch it, I can say, go fetch the thing named corners. And then the second is the value. Now, if you haven't worked a lot with Python storage before, I highly recommend getting into it because one of the really cool things about it is that it saves everything in its native Python type. So if, for example, I go ahead and save this, we're not going to see anything immediately, but we are saving all this data into storage. Now, what I could do is either middle click on the operator, and actually you can see the one stored items here, and the window gets a little bit crazy, so I don't recommend using this as your main viewer. But you can see that the list of lists is in here. If I was to go ahead and use something like an examine dat and drag and drop my script op onto it, you can actually see corners is a NumPy ND array, and then we can see every single item inside of it. And that's really great because that means that we're not transforming our data from one data set into a string and then having to, convert the strings to ints or floats later. Everything is kind of keeping its original type. So once I have that data stored up there, I can go ahead and make a script chop. And let's go ahead and edit my script here. And the first thing I can do is delete the custom parameters because I don't need those. And I can just get started immediately inside of my onCook area. So the first thing is that we do want it to clear every frame. That's fine. Then the next thing we're going to do is actually go and fetch that data from our script top. So what I'm going to say is, let's make a new variable called corners equals op. And let's get the name of this, script1. And we can say dot fetch. And then all we have to do is say what the key name is that we provided already. So we know we gave it the name corners. So now we have all that data that was, our list of lists is now immediately accessible to us inside of the script chop. Now this is really useful because script chop can do a lot of interesting things. You can just on the fly make channels, make samples, all kinds of different things that are really useful, especially for these kind of purposes. So what I could do is go ahead and pre-create my two channels. I know I'm going to want a TX channel and a TY channel. So I can say script op dot append chan, open a set of parentheses, and then give it a name. So in this case, TX. And I actually want to hold on to this object, this channel object that I'm making. I want to hold on to it because I want to access it and write data to it later. So I'll go ahead and even make a variable that says tx equals scriptop.appendchan.tx. And then I'm going to go ahead and do the same thing for my ty, so scriptop.appendchan.ty. And if you go ahead and save that, you'll see now I have two channels here with 0 values because I haven't done any value assignments, and only 1 sample because I haven't done any of that fancy stuff yet. And now what I can do is increase the number of samples because I want this to be dynamic. And we saw in our previous example here, the number of rows was always changing and the length of this chop was changing in relation to that. So what I'll do is I'll say script op.num samples. So directly accessing the script operator's, property that says there's this many samples. And I'm going to use the length of my corners object. So my corner object is a list. And just like we can do with any list inside of Python, I can say, hey, list, how many items are inside of you? Tell me. And the easy way we do that is just type len, and then we feed it our list. So now once I do that, we can see here if I middle click, the I, which is the sample, is constantly changing. So right now it's around 30. If I bring a lot of stuff into the picture with corners, you can see it goes up to 70, 90, or back down to 20. So now we have our channels resizing correctly. So what we have to do is now just go through this resizing data set and just plug our values into our TX and TY. So to do that, similar like we did before when we were doing for loops and talking about going through the corners, we're going to do something very similar here. But instead of just going directly over and iterating on each item of the list, what I like doing in this, and especially with the script operators, a good practice is to iterate over an index, and then you can call the data that you wanted from the original, whatever you're iterating over. But the index is also going to be helpful in a lot of different areas, because in this case, not only do we want to iterate through the list of corners, but we also need to know which sample we're going to be writing our data at in any particular time. So to do that, I'm going to start a for loop, and I'm going to say for I in range, because we're going to say, go over this loop this many times. And the nice thing is for the range, I can just use the same code that I used here to give me the length, which tells me how many items are inside of corners. I can copy and paste that in there. And essentially this becomes for every item inside this corners array, that's how many times we're going to loop. And I'm going to have a very steady index that goes from 0 all the way up to the end of that range. And this is going to be helpful because the way that we now have these samples set up, the way we write to them is going back and grabbing the channel object that we held onto, the TX and TY, and actually opening up a set of square brackets and say, okay, well, inside of channel TX, go to sample number I, and this is where the I comes in handy, and then we're going to set some value to it. So we can almost set this up very similarly for our Y here. So essentially we're iterating the number of times there are items in corner, the corners array, and then we're going to that same relative position in our samples for the TX and TY channel, and now we're going to write out some data to them. So now what we can do is we know what position we're writing in our TX and TY, and technically we know what position of data we want to get from our corners. So I could even almost say go to corners, go to position I. Now in this case, remember, each item in our corners list is actually a sublist, and inside of it we have two items, the X and Y. So once we get to the specific pixel we're talking about, we still have to go one level deeper, and in this case we open up another set of square brackets and say for the TX grab 0, the first item, and for TY grab item number 1. Now once I go ahead and save that, we can see we have essentially the same output that we were getting. This one's frozen just because I stopped clearing and writing to the table, but it's essentially the same kind of output. Not super slow, not super quick either. That's going to be in the middle range, and that's why, especially a lot of the time we talk about trying to find good ways of saving some overhead, like down-resing whenever you can going into these workflows, just because there are a lot of moving parts to them. But now essentially you have this really easy to use pair of operators that does the tracking, and actually in this case we're not drawing. So let's say we wanted to go back into our script and also just have a previs for drawing. So we could even go back to our example here, and they have a different way of drawing here, which works out fine, but we could just go back to our previous example, grab this image line that we had used before, and just put that at the end here right before we write the image to our copy numpy array object. Now one thing to remember is though, this is RGB, whereas our tops are RGBA, so we do need to go ahead and add that fourth component so that we have RGB and A. But now you can see I both have the preview, I've got my data, I can pull this data into an instancing setup, I could do all kinds of math on it, rescale it, put it into logic chops, filter it, create triggers, whatever we want to do with that data, we're now free to do very easily. So my other final tip is if you are using these workflows, one way you could probably get a little bit extra speed out of them is if you're finding that you don't actually need the visualization, so maybe the visualization is helpful sometimes, you can keep it on, but you can also go ahead and just comment out those rows. The row where we're doing all the blue shading on the pixels and the row where we're actually taking that numpy array and turning it back into a texture, you just go ahead and skip them. Behind the scenes, the operator is still running, the scripts are still running. As long as this script op is cooking, we're going to get that data, but then we're saving a little bit of overhead needing to draw all this different, pre-visualizations. So with that said, I hope that helps get you up and running and running even faster, I should say, using these examples of Opencv inside of the script top. Hey folks, thanks for watching. If you're serious about learning TouchDesigner and getting into our interactive and immersive industry, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner interactive professionals. You can click the link in the description to learn more about that. And if you liked this video, hit that like button. And if you're new here, don't forget to hit subscribe and click on the little bell icon for more awesome free content.